In this video we are going to continue the recipe topic, and we are going to create another recipe for a software package that is using CMake as its build system. This time we will be tackling something a little bit more useful. Raspberry Pi comes with some binary executables that are used for printing system information. If you have experimented with Raspberry Pi operating system book form version, or if you check the Raspberry Pi forums, you will see that these tools are used in order to get a lot of system information or configuration information and so on. So today we will be writing a recipe for these tools. First off, let me show you the GitHub repository that includes these tools. You can use this GitHub/raspberry/pi/utils in order to get to the repository. And we are inside the repository. As you can see, there is support for multiple tools. In this case, we are only interested in this raspi-info command and pin control command, both of which are widely used. And the others, we don't care at the moment. The others are most likely used for some device tray adjustment or video core information. And as you can see, as a build system, it is using CMake. So if I click to this file, I see that okay, it has many subdirectories that it is referring to. And if I say click onto this raspi-info, then I will get to the other CMake list, which will include build system configuration.
This variable is used later on in one of the recipes in order to make sure that
so now I think first we can check if there is any recipe available for this. We can do this from the Layer.Linux website.
So in order to do that,
click
since
this
we will
recipe
be
stuff
modifying
and
some
simply search
files,
it.
we will be creating
Let's go ahead and search. I
recipe
have
on
already
file.
done it actually, and
So
there
let's
is no
first
matching recipe.
check
Let's try utils for
what we
example,
did.
and if
Yeah,
we
I have already some
check
example
Raspberry
here.
Pi
Okay,
or
and
Raspi,
any,
there is
DT
nothing.
over there, right?
Okay,
So I can simply copy
we
this.
made sure that there is
I
no
will be
recipe
tailoring it,
for this.
of course,
We are
and
interested in
let
creating
me
this recipe.
keep this
So
layer
what we should be
structure in
doing
order to
is
create an
first
append
we
file.
are going to
It's
create
keep
our
this layer
recipe
structure
file.
in your own layer.
Let's go ahead
in
and
order to
create
override.
our folder.
Alright,
Let's
so
call
we're
it
gonna create recipes
Pi
and
utils.
then we are gonna create both files.
Inside, let's create also
and inside it
our
we are
recipe
gonna create
file.
a BB-append file that starts with the same name. So the package name and version is the same, but they're gonna add an append at the end of the extension.
Of course, here you
And
can
I
check
will
from
be
branches to
copying
find the
everything,
node revision. This
but
is
I will be
usually
removing
good
most of the
practice
things
to do
after
that.
this. So
In this case,
in
we
order
don't
to
care about
append
that, so
something,
we put the version as
in order to add a
1.0.0.
task,
That's fine for us.
we just need
Alright, so let's start first the
let's
summary.
not do anything else first.
Summary will be
All these
equal
definitions
to
are already done. We don't need to do it. What we do here will be executed on top of what's already available here.
Next up,
And
we have
then
the license.
Let's only keep our example,
Let's keep it closed
which is this one, inside
because
this
we're not going to be
task
publishing it.
function.
Then comes the runtime dependencies and the
let's
build
also
time
get rid
dependencies.
of
So
all
for
this
this, what
extra
I'm going to
stuff.
do is I'm going to simply check it. I don't expect much. Here there is no mention of any dependency.
We will be
Okay.
simply saying
Let's first check the
Pi
pin
0,
control. If
Pi
we have
5.
any dependency,
and
runtime
this
or
will be
build
simply
time.
added to this
It seems like there is
config.txt
no
as a separate line.
build time dependency. There is no find library or find package directive.
Just
We are
take a
good
build
with that
and
regard.
check what we
And
did.
what about the runtime? For the runtime, we can say bash, because these are obviously interpreted from the bash terminal. So
I made a mistake. I should
let's
have
go ahead
had
and do that.
this
So
append
our depends.
because I don't want to overwrite this
Package
do
name.
deploy. I just want to append some line just at the end of this do deploy function.
And
I want
now
to keep
we
all
can
this.
give our source URI.
That's why we added the append here.
The wrong one.
In one of the
Details,
later
go ahead
lectures,
and
we
copy
will go
this.
into detail about the syntax, but for the sake
Source
of
URI
our
equals.
purpose, which is enable serial and SSH,
We will be
I
pasting
think
it.
it's sufficient to tell you that you should
Rename
have
this
this
to git.
Let's start
git
again
protocol.
and check. Alright, so the build is now complete.
Yes. And branch.
Let's check our output.
What will the branch be?
Go
Inside.
inside
Alright.
this directory, then I will go to this command line recipe first
And then
and find the command line file
let's give our revision.
and
As you recall, I can simply make this
Check.
automatic so that the last
As you can
commit is
see
always
now,
used, but
our kernel
I would
command
like to
line,
freeze
which
it,
has
therefore
for
I will
bootloader to
put
kernel,
commit ID here in this
states
case.
this console
So what I can
equals
do,
TTI
here I can
AV0,
go
which
to
is the
commit, I can pick the last one,
which is
and then I can
the
copy
serial
commit
console
ID
that we
from the
want
address.
to redirect the kernel output to.
Put this one
And
here. Alright,
during the boot, we will see these
and
D
since this is a
messages,
good
right?
recipe,
These
we
D
will be
messages
defining
we
our
will be able
S
to see. And
source directory.
here we are basically instructing kernel to redirect its output to this.
Alright, so here comes the important part, which is
Alright,
to use
so
available
but
BB
of course, in order for this to
In previous
function,
examples,
we should
we
have
have
this
only
driver
tackled
available.
one example
so
with the
that we
GNU
have
make and
this
one example with the simple
available in the
compilation.
system.
We are
So
fine
we
with
did
those,
that
we don't
by
have to
doing
inherit any
integration in
BB
this
class.
public.txt
In this
file.
case, for the CMake, there is
And
already
let's
available
go ahead and
BB
search
class that is
for
handling most of the tasks,
TXT.
even the compilation. So we will be using the class. Yeah.
Deploy.
Just for the sake of completeness, let me first show you the class.
At this file,
Go ahead.
and as you can see, we have added the device tree overlay, which simply enables the driver,
Meta.
which is good, and also we have this enable UART equals 1 statement. So basically all the modifications that we did here and the BBFN file that we added here achieves the tasks I just showed you. With this now, when
Here
the
you
board
can
goes,
see
we
the
will be able to see
CMake
the
class.
serial output, but we will do this in another lecture. So that being said, thank you very much for following the lecture, and I will hear you in the next lecture.
You can see the configure task here. You can see the compilation task and install task. Compilation and install tasks. Alright. Let's go back and inherit this. With the CMake, since this package config is also used, so this package config is a tool to handle dependencies, it is good practice to also include this one, although in some of the software packages system won't be using this. What we will have to do is only deploy the files wherever we want. So I don't think this CMake deploys the files anywhere based on what I checked. Let's check together again. No, actually it is deploying somewhere. So let's leave it for now. Let's experiment. If the file is deployed to some place that we don't care about, we can simply add our own to install. Alright. So I think we are now in a position to simply cook this recipe and see what comes out of it. So through this one. Actually, we haven't modified the CMake lists txt yet, so it will try to build everything, and since there are a lot of dependencies with this device tree stuff, I'm expecting an error here, but we will get to it. So we will be modifying the CMake so that only Raspi info and the pin control commands are built. Okay, just as I suspected, there's this libfdt, which is library regarding this device tree overlay. Therefore, we have this error, but we don't care about this device tree overlay tool or device tree merge tool. So we will now be simply modifying the CMake. So one thing that you can do in this regard, you can simply create a local CMake, and you can add it to the source URI. So let me try to do this. Let's try to do this together. We have created a files folder, and inside we should be actually keeping this original source layout in the source. So let us check. Okay, so there is this cmake lists.txt that we would like to modify, and it is right under git. Therefore, what we should do is we should create another folder here, keeping the source structure. Then inside this one we will be creating cmake list. And we will be simply copying the cmake lists from here inside this one, and we will do our modification. So basically what we want to do is simply command anything that we don't want. In this case, everything besides the bin control and Raspberry info. And what we want to do is add this to the source URI. So what happens when we add this to the source URI? It will be simply deployed to the exact same location, this one, and it will be overridden simply. That's what we would like to achieve. This time we will be giving a local file, so we will start with this file, git cmakeLists.txt. There is something else I'd like to mention. We are free to include one statement also that is simply used for extending the search path for these local files. What I mean is this files is default. It is by default searched when you give any source URI item that starts with a file, but you can simply rename this to some other directory, or you have something different, right? In order to simply extend the search path for the source URI, you have to give one statement. Just for the sake of learning it, I will be using it. It goes with files extra path prepend. You give a semicolon, meaning that you are extending it. Then you will reference this directory, and then you will go with files. In this case, we don't need to add this. We can simply change the name to files2, and then we have to do the same here. Okay, so now that we know this also, and now that we have simply modified our CMake and added to the source URI as a local file and made sure that the path is the same, the CMake lists in the source in the location that I've already shown you will be simply overridden, and hopefully it won't throw any build error regarding this device tree. So let's go ahead and compile again. Okay, we have a problem. Let me examine the issue. Okay, it should be files extra paths, not path. I believe that is the issue, so let's try to do it again. Okay, we have an interesting problem here. Let us examine the problem. Okay, so it is basically saying that these folders are not found. In order to debug it, we can simply go inside to check what kind of mistake that we did. And we will be going inside this folder and inside git. Oh, and you can see that we have somehow overridden our source URI. So we give one source URI and then we have overridden it. This wasn't supposed to, this shouldn't have happened. So we can use this plus operator in order to add something to it actually. We want first Git to be cloned and then on top of it this CMake list to be copied. Of course I will also give this spaces and then let's build again. It's looking good. So the compilation was successful. Everything other than this QA stuff was successful. And what is this saying? It is saying that some files or directories were installed but not shipped in any package. And it is giving me actually what paths are simply deployed or shipped. So this is interesting. Now we see the build outputs here, and it is some USR share folder stuff, right? So after all, this tells me that we should specify this to install, because the current one that is available with the CMake list.txt is apparently deploying these stuff, but we don't want these stuff. We want simply, this is regarding the bash completion, by the way. We can also have this. This is not bad, but I want this pin control to be available under USR bin. So first let's handle this. This will be really simple. And let's check where the binary is located actually. Okay, inside this one. What about the other one? Other one's not located here. Where is the other one? Where is the other one? Oh, we have a build folder. Okay. This is really weird. So what we have here is we have this pin control under the build folder, but this Raspberry info binary is not under the build folder, it is under the source. So this tells me a faulty, of course, CMake list.txt, but we don't care about it. We will simply write our to install task based on this knowledge. So first, what we can do here, we can simply copy from build folder, pin control, to USR bin, and the other one we will make from the, we will copy from the source. Okay, let's give this one a go. Alright. Let's check on the image if what we deployed looks correct. Okay, so what we deployed looks correct, but now we have to set our package file outputs so that this error is gone. So remember, what we did in this case was simply set up our separate packages, and then we use this files variable to simply allocate the files to the packages. In this case, we are not going to be creating a separate package. We can just specify files for our own package. Okay. So first of all, we will simply give this user share dash completion. I think if I give this one, I don't need to give any of the other ones. Let's give this one. Actually, let's give this one. Okay, what about the others? We have also deployed some stuff. So let's also give those. Don't forget the spaces. Okay, perfect. Now everything is good to go, so let's check the outputs again, just in case. As you can see, we have deployed this share and then this bin. Share is simply for dash completion, and the binaries we have deployed ourselves so that they can use from inside the Raspberry. Let us actually flash our image and see what these tools are doing. Alright, so my image is ready. I have only did one change, which is inside the local conf. I've simply added this one, and I took the image simply. I used the BitBake Core Image Minimal in order to cook the image recipe. Alright, now I have flashed the SD card also, and now it is ready. So what I can do, I can simply use Minicom. And I'm already inside, and let's try to use the command. So okay, it is this one, Raspi info. And as you can see, once I run this, basically a lot of system information is outputted, starting from what kind of device it is, and yeah, some uname output. Video core, we don't have access to this command yet. File system information, some package information is missing, networking information is there, and command line information is there, and so on. Okay, so basically our recipe is working. That being said, I think it's a good point to wrap up this lecture. Thank you very much for your attention, and I will see you in the next lecture.